Hello, how are you? Today I want to show you a really cool theorem about polynomials. So let's have a polynomial. Here's a cubic polynomial, and let's suppose a, b, c, d are real numbers, real constants, and z is the variable. So now the roots for this equation, let's say z naught is a root. It means that you substitute c equals z naught, you will get the right hand side equal left hand side, 0. Now I've substituted in z for z naught. Both sides of this equation is equal. So why not we take the complex conjugate of both sides? So the complex conjugate of 0 is just 0. Then we look at the right hand side. The thing about complex conjugates is that if we have a bunch of numbers added together like this, and then we complex conjugate it, it is equal to, the right hand side this one, equal to the complex conjugate of each term, then added all together. And each term is, for example, this one. We multiply a z naught q, then we take the complex conjugate. So that is equal to also all the terms complex conjugated, then multiply together. As a side note, z naught q complex conjugated equals z naught times z naught times z naught, then complex conjugated, and as we've seen already, we can also complex conjugate each z naught first, then multiply all of them together. Alright, so that's why this is the case. We have assumed that a, b, c, d are real numbers. Now the complex conjugate of a real number, this is a real number, it has 0 imaginary part. Complex conjugated, we do not do anything to the real part, we only swap the sign of the negative part. So this is the complex conjugate of a, which is still a. Oh, alright. B is also a real number, complex conjugated is still itself. That's interesting. So if this is true, then this is true. Now, can you see that the complex conjugate of z naught also solves the equation, this cubic equation for that matter. Ooh. So if z naught satisfy this equation, then just complex conjugate both sides, and we have this. The complex conjugate of z naught also solves the polynomial equation. Therefore, if we generalize this to other polynomials, it can be quartic, quintic, quadratic, linear. If we have a polynomial with real coefficients and z naught is a root, then z naught complex conjugated is also a root.